In this video, we will go through source of errors and improvements within the scientific method. So looking at source of error and improvements, so using that scientific method, we can design experiments to try to obtain results that prove or disprove our hypothesis. Basically, we're testing our hypothesis. However, experiments are never flawless. Despite thinking you might have an amazing, awesome experiment, it's always going to have flaws to it. And scientists know that their results always contain errors. You just have to accept that it will. Your goal when designing and performing your experiment is to minimize your errors and to be aware of what errors may be present in your experiment. You should also consider these errors when making your conclusions. Since all results contain errors, scientists almost never give definite answers. They are more likely to say it is likely or it is probable that when making conclusions. They will, you never use strong language such as, it was proven definitively that, X affects Y. You're more likely to use, it's better to use suggestive language, as stated in the paragraph here. So it is likely that, or probable that, or the data suggests that. You're never going to say the data proves that this happened. The data suggests that this happened. As a science student, you too must learn to evaluate your experimental design and results and critically assess those and report them in a way that indicates your confidence in your answers. Basically, acknowledging the errors and limitations of the experiment will add objectivity to the process and to the findings. So there are two main types of errors one must consider when evaluating their experiment. So there are random errors. These are errors beyond your control. And these errors occur because it is impossible to be 100% precise when taking measurements. You have little to no control over these errors. So some examples would be, you can only be so accurate when reading a ruler or a graduated cylinder. And, for example, the temperature and wind currents in the classroom will vary depending on the time of day and the number of students present. So this can have an effect on the readings that you might make, for example, and you have no control over it really. So how to reduce the effects of random error would be to take an average of a number of trials. So when you do an experiment, you never do it once, you do many repeats. And you average those repeats together to try and account for those random errors. The next type of error is a planning error, and these are errors caused by the way the experiment was designed and conducted. So the instrument equipment you are using is not working correctly. So for example, a scale reads 1.0 grams even after it has been tared, or 0, so after you zero the scale, it's still showing a mass and not 0. Another example would be a tape measure has been stretched from years of use and no longer gives an accurate measurement. So how to reduce effects of planning errors? Planning errors cannot be eliminated by doing multiple trials, but can be eliminated by changing your procedure or the way you perform the experiment. So, if a particular piece of equipment is not reliable, you could change it out. Or if it's not accurate, you might look at another way of performing the experiment. There is a third type of error to consider, and that is human errors. Human errors usually result from making a mistake, spilling part of a solution, dropping part of a solid from the weighing paper, or doing a calculation wrong. These are basically considered mistakes and not errors, and they can be avoided by being careful. So we never report human errors. Nobody wants to hear about your incompetencies or the incompetencies of your lab partner. So nobody wants to know why everything is your lab partner's fault or why everything went wrong. The following examples are not true errors. They're basically mistakes that should have not happened. So, for example, spilling or sloppiness, dropping the equipment, bad calculations, reading a measuring device incorrectly, not cleaning the equipment, using the wrong chemical, not following the planned procedure. These are all considered human errors and basically boils down to the experimenter not being careful. So there are improvements, that can be done, and you should always be looking for improvements in how an experiment can be conducted. So after completing an experiment, scientists always review their results and evaluate how effective their experiment was. They look for ways to improve their design and procedure to obtain more accurate results. As you are performing your experiments, you too should be thinking about how you could improve your experiments to minimize errors and maximize accuracy. Suggesting improvement should not be viewed as a bad thing. As stated above, all science experiments have errors. In order to get valuable and usable results, these errors should be as minimal as possible. And just note, as you're performing your experiment, you should be thinking about how you can improve your experiments to minimize errors and maximize accuracy. So a little bit of practice here. So which of the following characteristics are characteristics of random errors and which are systematic errors? So just write an R for random and a P for planning. So you can take a little bit of time, answer those questions, and we'll go through them at a later point in time. So here is a practice problem that can be worked on as well, and we will discuss at a later point in time. So, save your questions for class time. I'm sure there are plenty of them, and we can certainly discuss a lot further. So that is the end of this video for sources of errors.